Welcome everybody to the second to last lecture of this academic year. As you know, I'm Daniel Ibañez, I'm the director of IAAC, and it's my pleasure to welcome Michael Green to IAAC and Kelly and Maria that I'll introduce in a while. As many of you knows, IAAC has been always at the forefront of many I would say small revolutions in our discipline. When nobody was talking about digital fabrication, we had the first kind of fab lab in Europe. When nobody was talking about sensors and the importance of data and information in cities, we were kind of crafting here the Internet of Things. But also many years ago, I would say almost like 15 or 16 years ago, IAAC also made a big bet on bio-based construction. Back in the days, we managed to do the kind of iconic Fab Lab house that was a very kind of unique and special project that also was made with mass timber, one of the first. And since then, that's a line that has stuck very close to many of the things that we do. As you know, with the extension of IAAC in the campus of Vaidaura, that's a line that we have been trying to push forward very, very much. Talking about, mass timber design, mass timber architecture, and not mentioning Michael Green is almost like impossible. They go hand by hand. Michael, I would say it's probably, if not the top three, the most important architect working with mass timber, the one that has not only done fantastic buildings that today serve as an example, as iconic I would say references to follow on this massive transition for a decarbonizing architecture that is bio-based, but also somebody that has had the difficult task that some of us also we are experiencing these days in Spain of creating and opening the path for others to follow. Like being an innovator, being a change maker is very, very hard because all the barriers are there for you, and you are the first one to need to overcome. So again, more than admiring the work of Michael for many years, I also appreciate that he has helped many others in many different geographies, in many different locations, also to follow and try to to open those paths for a bio-based sustainable construction. So today, basically, we have a kind of special format. I've asked Michael to kindly give us a relatively short lecture so he can share some of the contributions he has done in the field. And then knowing that Kelly and Maria, that I'll introduce in a minute as well, are here, we will try to have a conversation, so more like a dialogue, and hopefully we'll have some time for questions later on, so you guys could be as well engaging. So I have a lot of formalities, but I think we can skip them because I'm sure most of you know them. But again, please join me in welcoming to IAAC Michael Green. Thank you.
Oh, that's fun. Okay. Hi. This is a fun lecture. Of all the lectures or the talks I've ever given, I've never sat down. So this is going to be fun because I have to slouch to do this. So my apologies as I lean over here. And my apologies that I don't speak Spanish, but hopefully this is okay. I'm going to tell you a pretty quick story. I'm going to talk for about a half an hour. I'm going to tell you the story about what we've been up to and why we've been up to it, and some of the things that we think are really important to think about when we act as designers. One of the things that's always been most important to me is that we design for our individual clients, all of us do when we're architects, but really we are designing for our entire community, and we're designing for the world, right? We're designing for many people that aren't in the room. And we have a deep responsibility to think beyond the limits of our individual project and to think about what we do in the context, not just of the city, but of the big conversation about our industry. I think our industry is one of the most important industries on the planet that has one of the smallest voices on the planet. And we collectively, and you students are a huge part of this, have an opportunity to transform the meaning of what we do by talking about it in a context that everyone else outside of the profession understands. And the challenge is we've had a history of talking about our work for what it looks like, styles, and not the meaning of what it actually means to society. And we have to change that conversation. And so in our practice, that's really been from the beginning something that's important to us. There's a long story of how we ended up in wood, working in wood, but we've got about 45 people right now. So we're a mid-sized firm. Weirdly, we're actually up for Architizer. If you guys know what Architizer, we're up for the Large Firm in the World Award against Norman Foster. So consider voting for us. That's a voting thing. It's my plug. I've never done that before. And it's also weird that 45 people is a large firm, but it speaks to our industry a lot, right? I put this slide up where we are. So we're in Western Canada. We're in Vancouver, Canada. We have a little office in Victoria, which is near Vancouver. And then we're starting to set up a practice in New York, and we're starting to set up a practice in Spain. And so we'll talk about that in a little bit here. But Maria, who's one of our senior associates who's here, Maria Mora, lives in Seville. So we've already had this presence here, and we're going to start working more and more. And Kelly's in London. You'll meet Kelly in a minute too. So our practice started as a timber practice. We only work in timber. We will not accept commissions in steel and concrete. That was philosophical for us when I restarted the practice. So I've had my own firm for about 21 years. But I restarted the practice as a timber practice about 13 years ago now. And that decision at the time in North America was very unusual. We're the only all timber practice in North America. And it was because of a lot of the work we were doing advocating to move towards all bio-based buildings. And for us, the sort of answer, and I use this just in talking to clients of why, is this sort of really simple version is climate, of course. You all know this, and I'm not going to explain mass timber because this is one of the great talks I get to give with a bunch of people that already know what that is. But it's about a whole bunch of reasons we do it. And the foremost reason for us has always been climate. And so, as you all know, for about 75 years, we've had a really clear sense that carbon is impacting the climate. And we've, my entire career, done a very poor job of actually embracing what that means. And thankfully now we are finally all starting to really dive into what that means. And I know that's a huge part of your program, so that's really great. But that 42%, which is the global anthropogenic impact of climate, 42% of all greenhouse gases is much higher in North America. So it's almost 50% in North America of our greenhouse gases is the building industry alone. And so I won't go into that. I think you guys probably all know embodied carbon, operating carbon, embodied being the conversation. And that brings us to wood and brings us to other bio-based materials, right? We have to find the tools that are going to help us to store carbon in the building materials and reduce the carbon footprint by using alternative materials, to especially steel and concrete. We've always been committed to structure because I believe every great movement of architecture has been born of structure, from the earliest architectural definitions of the Egyptians, the Romans, the Greeks, every major phase of architecture is somehow right into modernism and defined by a new structure. And we are in the first moment in over a century where we have a new structure. It's really an old structure, right? Wood is not new, but we're using it in a new way with engineered products, and it gives us a chance in our field to really start imagining it. And what's great being here is the kind of work you're doing with 3D printing and sort of understanding what that means in lots of different materials. So it's obvious that's a big part of the conversation that you guys have already going. Tall wood, there's two terms that actually weirdly our firm invented. One is tall wood, which comes from the first book I wrote about this about 15 years ago. The other is, believe it or not, mass timber. That's a word we invented. And we invented it because mass timber wasn't, CLT, which you guys all know, wasn't a material that we could use in North America. We had to use other materials. And so we started to explain it by using this word mass timber, which which, you know, we were all trying to figure out how do we describe these materials. So there's a whole family of mass timbers, and that became really important to us, especially because where I live, British Columbia, is a forestry environment, right? We have huge trees. Forestry is a big part of our economy. And so reinventing all kinds of different types of engineered panel products to make what we call mass timber became really important for us because we had no other option. We would at that time when we first started doing a lot of these buildings, we would have had to import CLT from Austria. That was our only option at the time. And so we developed this mass timber and we built in all kinds of different mass timbers. And that's important to us because CLT is great. It's not always the best material. It's a really good one, but we like to use all different ones for different applications and especially for different cost benefits. We did a bunch of work in the early days when we first started pushing this idea of moving up in height. And I'll just tell you a quick story of why we started talking about tall buildings and wood. I had been in Austria. The Austrian government, we had the Olympics in 2010 in Vancouver, and the Austrian government in 2004 asked me to come visit Austria because they wanted me to help them build their Austria house for the Vancouver Olympics. And they gave me a tour of the earliest days of CLT. And I met some really amazing architects like Herman Kaufman, who's one of my favorite architects. And through that, I became a believer and started really focusing on wood in our own practice. But the way wood was being used in Austria at the time was to build 2-story tall buildings, maybe sometimes 3-story tall buildings. And that's because it was a good way to break into what otherwise is a concrete housing market in Austria. So they invented CLT to be competitive with that marketplace. For us in Canada and in the United States, we build what's called light wood frame housing, right? Made out of 2x4s, if you know that term, dimensional wood, small scale wood. And so for us, we can build 6-story buildings in light wood, and that's really, really economical. So we knew right away that CLT was not going to be economical in North America if we were just building buildings under 6 stories. So the transformation for us was realizing, well, if we want to use this material, where can we use it? And that became this idea of tall. And as I lectured around the world a lot about these ideas in the early days, I got to know Andrew Waugh, who's one of my best friends. If you don't know his firm, you should. Waugh Thistleton. And Andrew built the first tall wood building, which is called Murray Grove in London. And then we had the good fortune of building the second one, which is this one called the Wood Innovation Design Center. It's not very tall. It's in a small town that didn't need a tall building, but we used this building as a real test for us to understand how we could build these buildings. And this is, was our first, in this case, this is actually the first CLT building, or the second. We had done the first CLT building in North America, but this is the second one that's proper tall building. And this was done by our government to really help us understand and test all kinds of different innovations. And so we didn't have to follow our building code. We got to push things. We wouldn't normally be allowed to do wood on the outside of a building. We were able to test all these ideas. And when we got to the end of that process, we did a comparative life cycle assessment. And this was in the early days for us of LCAs, but there were 2 different studies done comparing the building to an alternative that would typically be built in concrete. And it was an 88% reduction. And we use this little fun tool, and this is really just a quick way to explain it to lay people that the North American forest grows enough wood every 4 minutes to build that building, because people always want to understand that. And that's true, but there are some scary limitations I'm going to talk to you about in a second about that. So we've gone on and we've literally built 50 mass timber buildings or more now. It's every different type of building. This is a university project we did in Oregon. It's actually a forestry school in Oregon. This is a city hall. And again, this was before we had mass timber. So this is all prefabricated panelization using what laminated strand lumber, LSL, if you guys know that one. That's another mass timber. Again, because we didn't have those materials. And so this was all for us in education, right? We're trying to figure it out. And while we're figuring it out, we're also trying to understand how to tell a story. And we wanted to figure out, how do we make this relevant to people? Because the conversation constantly was, that's too confusing. Our industry isn't going to change. The construction industry makes lots of money doing things the way they already do. Why would they ever change, right? That's been a big battle to change an industry that, if you think about it, largely has not seen any major innovation in about a century. I mean, there's been cool things that have happened, right? We got insulated glass, we got some technology we all use to design buildings, but really we haven't seen huge leaps forward in our industry in quite a long time. And so there was a lot of resistance. That led to a TED talk I gave that really changed for us in our practice everything. It was an opportunity to explain to the world, and again, what was most important, in terms that everybody understands, not in architectural terms, but in terms that we tried to connect with as many people as possible, why we need to change the construction industry and build with low carbon materials. And what was really interesting for me in the experience of giving that TED talk was that it did reach a lot of people and start to really propel this idea into an international conversation. But the most important thing, believe it or not, there are two things that were really important. One was that it was translated into 40 languages. And so that allowed all these other countries that didn't have English as a primary language to start to look at these ideas. And the second was that the ideas that we promoted were all Creative Commons licensed. And so you may know what Creative Commons is licensing. It's different than, traditional intellectual property where you try to hold a patent on an idea. It's actually the opposite. It's about sharing the idea. And when I wrote the first book on this 15 years ago, we wrote that it was all Creative Commons licensed. And that idea was that, nobody should own steel construction. Nobody should own construction methods, because if you do, I don't think we'd have steel construction today. We have to share these ideas. But what was also really interesting, and it's a good story to just share because it's not something I understood at the time, was the only reason the idea grew and helped us raise this idea bigger and bigger and get these bigger audiences to tell the story was because we gave it away for free. So the media, who wrote lots of articles about these early ideas, it seemed crazy to build tall buildings in wood. What they said is, we wrote about it because it was so strange that you didn't own it. I love that. It's so strange. Normally, if we were at our office right now, my dog would be running back and forth and causing havoc. So because we gave the ideas away for free, the media said, this is a great story we want to tell. If you owned it as a patent, we never would have told the story, which never occurred to me. But the message as architects is our job is bigger than ourselves, it's bigger than our practice. It's to find ways to get big ideas out there and to share them. And so that sharing for us actually turned into opportunities. And although it wasn't obvious at first, it turned into opportunities like this, where Google hired us to do their two first mass timber buildings and on their main campus in California. So we generally don't talk about these projects a lot, but we're just starting to. This is actually the second Google project on the main campus. So this one's actually I've never shown before, but it's an all mass timber building. I'm going to show you a second one that we are talking about now. And this is a building, it involves a whole bunch of different buildings for Google, but this is actually the first Google project that we did. And we worked with them right from a kind of research and development point of view to figure out what would work for them. And there was some really cool, I'm going to show you some calculations in a minute of how we helped them get aligned around this beyond just the climate benefit. But this building houses about 1,000 Google staff. It's got it's Google, so you get to spend some money on things. It's got this really cool closed cavity glass system that had never been done in North America. It's big central atrium space that's pretty epic in mass timber, and the scale of space, the floor to floor and parts that are about 9 meters and other parts are, I guess, 5 meters, 4.5. So, just huge scale project with lots of beautiful, fun detailing that we could do. This is the north side of the building and lots of daylight. They have some really interesting requirements. But what I wanted to get was to this slide, which was, again, a life cycle assessment that was done on that building, comparing it to a building that had just been completed nearby by a very famous architect who I'm not going to say. And it was a 96% reduction. The other fun part for us, that it was also 1/4 the price per square meter of that building that was that much more carbon. Two different solutions, two completely different outcomes. What makes us most proud is that Google came back, and the senior leadership of Google came back to us and said that, and this will be hard for film because we don't want to record this, but they said that that our building is their favorite building they've ever built. And we received that from so many people. So it was 1/4 the price per square meter of some famous buildings, and and um, and this much reduction. And even better, one of the founders at Google said, "That's really great. 96% reduction is great, but how do we get rid of the other 4%?" Which is exactly the kind of question you ask if you're the founder of Google, right? And it's exactly the question we are all asking each other, right? Because these calculations, by the way, and Kelly, who you're going to hear from in a moment, is far more knowledgeable about LCAs, and some of these are, pretty generic calculations, and I don't entirely trust them. But the point is, the momentum of what these buildings can do is obviously very important. We've been able to work in other places now. France, we did a bunch of work with the mayor of Paris about 12 years ago, and she was really excited about these ideas, and that turned into work. This is a project in Paris we just finished last month. I don't have pictures. I'm only going to show you guys a few more projects, unfortunately, right now. But this project we've just been awarded. It's 55 stories tall, which will be definitely the world's tallest. This is a very, very early concept. It's actually 3 buildings, about 120,000 square meters of mass timber. So it's huge. It's in America. We've been chosen to do this project, but we still have a few hurdles to get through. But the city is very excited about it. So the point is, mass timber is off to the races. The ideas that we were all told couldn't happen obviously are, and it's really exciting to see what's happening here in Barcelona and throughout Spain now, where you're starting to see these buildings happen. The funny thing about projects like this, and again, this was like a 1-month exercise for us, so the design is going to change. This is just like very, very preliminary thinking for this actual design. But what was interesting about doing this for us is that, weirdly, I have a partner, Natalie, who's the other partner in the firm, and neither Natalie or I are really tall building people. We don't get super excited about tall buildings. Don't tell our clients. We'll happily take more of them. But it's because we historically build tall buildings, I think, without enough sort of deep sensitivity to how to build community. They really can be very socially isolating. And so we're trying to push that our towers actually really address community-based living, which is very different scale of number of units to create community. And so we're really pushing developers when we do tall buildings to rethink, especially in the North American context, how we think about building tall. Anyway, I always say this is that, because of the work we've been doing, everybody's like, "Oh, you guys are so sustainable," and I think that's total bullshit. We're not sustainable. We're kind of getting more sustainable, but we got a long way to go, and our whole industry has a long way to go. And this word, at least for us in North America, has become dangerous, because the number, I mean, you're probably all meeting people that do this too, and they're like, "Oh, is that building LEED, or is that building got some certification?" And then the public think that therefore we've done a good enough job. It's a disaster, right? We have to push so much further than these systems that we have right now. And this word is making people feel like we've done enough, and it's nonsense, right? The number of times we've seen, stupid Frank Gehry buildings, which have 200% more steel in them than they need to, have a LEED platinum label on them, shows you how broken our industry is, right? And by the way, I'm more than happy to call out that shit, because that's fucking crazy nowadays. I'm sorry to say. Like, it is, we have as an industry to grow up and stop celebrating the nonsense and start celebrating the meaning of what we do, right? So here's the challenge, right? So when I think about sustainability and I think about mass timber, this is truthfully the challenge. The global forest is only so much of the global forest is really appropriate for sustainable harvesting of forest. Much of the world shouldn't be harvested, and is actually quite threatened, right? As we all know. Climate change is changing the forest extremely quickly. It's super cool to hear that you guys have a forest to go and do work in. That's amazing. That's the best thing you can have, is to spend time in the forest. But we're seeing major migration of tree species moving north in North America. We're seeing huge die-offs. I was just in the Dolomites not too long ago and seeing huge beetle killing off huge tracts of forest. the threat to the global forest is huge. And so this idea that we can solve the world's problems by moving away from steel and concrete to mass timber is only a tiny part of the story. It's not good enough, right? And even more so, where people live is in this part of the world where there isn't really forest that's sustainable to harvest. And so if we want to solve problems for us in Canada to build one nice building or to build a building for Google, it is not going to solve the world's problems. Our investment in every decision, every building we do is how is this going to hopefully change a bigger systemic change for the world, right? And I don't think mass timber is going to solve the world's problems. I think it's going to help. I think we have to invest hard in it. I think it's really important in Northern Hemisphere and extreme Southern Hemisphere countries. I think it's important in Spain. I think it's important throughout Europe and North America and Australia, New Zealand. But I think when you get into the middle part of the world, we have some bigger challenges, right? Of protecting the forest is also part of the plan. And so we've been thinking a lot about it. And I like that you've been thinking a lot about it. And we always ask this question, right? What are the alternatives to the big four structures? Steel, masonry, concrete, and wood built the planet for the most part, right? And I always think that if we asked a century ago the iconic architects that we all still love, the Corbusiers and Mies van der Rohes of the world, they if we asked them what structure they would have thought of had they known about climate change, I think we might all be building very, very different buildings today. But we didn't know, and we do now, and we have for a long time. And so the question really is there a fifth, right? Or maybe sixth, seventh, and eighth? I don't know. But this question of five is part of the empowerment of our industry. The construction industry, I'll get to it in a second, about the scale of it, is so big that we have a big voice. We have a big economic engine. I'm going to show you some numbers in a second. But what we've been really intrigued by is if it's not wood, plant-based fibers combined with natural binders and structural modeling and robotic forming is something that we're starting to explore to make a plant-based structure that will be an alternative. I don't know if we're going to figure this out. We want to build a big global network of it, but our hope is that we can start to think of other agricultural products that are regionally appropriate and even waste products from different parts of the world that start to think about how structures are made. Wood is effectively cellulose and lignins. It's really the properties of vascular plants that allow us to start thinking, are there other plants that can be part of the story? So again, I think mass timber is the answer today, but not forever. I love that what you're doing is trying to figure out what's next. And again, it needs to be regional. It's not just global. It also needs to consider regional things like what you guys are doing, and more earth-based systems probably don't make a lot of sense in the rainforest where we live. But they make a lot of sense here. So there's going to be regional solutions too, right? So as we went through this whole movement of mass timber and kept pushing and pushing people to do this, this is the question that kept coming up. And for a long time, I've struggled with this question because it's just the wrong question. Is it cheaper? The reason most people don't build this way is because of this one question. They just want it to be cheaper. And I kept saying it's unreasonable to this is the first new way to build a skyscraper in a century. It's totally unreasonable. Sorry, by the way, sorry, this side of the room. I'm looking this way because the microphone's this way. I gotta let me try to move over a bit. Yeah, this question is actually a huge problem. And it's become something that we've gotten really interested in because it's the question of why does our industry not innovate or embrace innovation? And it's because the drive for most people outside of this room is what's the cheapest way to build, not necessarily what's the best way to build, because we talk about it wrong, right? So I'm going to use a couple examples to explain this. I just gave a TED Talk last week or 2 weeks ago that'll come out about this, but it's an idea that we have about how do we really start creating other opportunities for innovation. That's about raising a lot of money that comes from people that have a lot of money that should think about our industry that haven't been thinking about it. And it comes from a huge shift in the way we talk about the true cost of buildings. So let me walk you through this because I think it's kind of a cool and interesting, well, hopefully you'll think it's interesting conversation. So I'm going to give you the example of construction noise, but this is an example. So how many of you guys have had a hard time studying at some point because of construction noise? Like a lot of us, right? or a hard time sleeping or a hard time working or whatever, right? So we're all used to construction noise being a huge annoyance in our lives. But here's a crazy statistic. This is a European statistic put out by the World Health Organization. Every year in Europe, 1.6 million dailies, that's what's called a disability adjusted life year, are lost because of construction noise. So what that is, that's hard to wrap your head around. That's basically people getting earlier onset dementia, earlier onset Alzheimer's, earlier onset other aspects of mental illness that the World Health Organization has connected back to construction noise. So on the one hand, we think of it just as an annoyance. It's actually reducing life expectancy in Europe and all over the world, right? Because it is such a massive common problem. And it's not just an annoyance, that's a real cost. That's a cost to society that the construction industry does not pay for, right? So what I mean by that is the example I give is when we built the first tall wood building, the only thing you could hear on our construction site, because mass timber is such a quiet way to build, was the sound of the Delta Hotel being built 7 blocks away out of steel. That's all you could hear on our site. So the cost to society, that healthcare cost of people's lives being impacted by the construction noise is so significant that 2 completely different ways of construction actually can have a real cost difference to society. But because we don't attach that cost to the building cost, it's not considered. So mass timber is more expensive. So what I want to explain to you is why innovation is directly attached to the way we talk about cost. If we expect every new idea to be the cheapest solution using our conventional way of measuring cost, it is very hard to change our industry. But if we completely transform the way we talk about cost, we will see these new innovations actually become the real lowest cost solution and therefore be implemented, and more importantly, see mass global investment in what we do. Creating this conversation means completely transforming the way we talk about costs, and that's like very, very hard to do. And let me just show you what I mean. So what do buildings cost? So I don't know for sure that you guys do the measure things quite the way we do, but this is the way we measure costs in North America, and I think a lot of the world does. You have what we call hard costs, so that's labor and materials. And then we have what are called soft costs, so those are like design fees and engineers and architects, permit fees, taxes, the interest on the loan for the building or the property, regulatory process, that kind of stuff. And all that together equals what we call the project cost. And that's it. That is the only way we talk about cost. And when we talk about a mass timber building, is it cheaper? The only thing that our clients are ever talking about is the first one, the materials and the labor, right? But a mass timber building can be built faster. And that means that second cost under soft costs, under loan interest, if you can build the building faster, you actually pay less in your loans. So that should be considered, right? But we don't talk this way in our industry. So we only talk about hard costs, and therefore it seems like sometimes mass timber buildings are more expensive, but it's an incomplete conversation. And more importantly, that's just with how we currently talk. Really, project cost is just a tiny part of the puzzle, right? So, and this won't surprise you when you see it, but you have to add planetary costs. So that's carbon. We don't cost carbon, but there's lots of planetary costs that should be factored into the cost of buildings. Then there's societal costs. There's performance costs, and there's process costs. All those costs together are what we're trying to rebrand. And this is what we hope is like literally the next word, like mass timber, that becomes the global word, which is true cost. So it's a little bit like life cycle cost plus a whole bunch of other factors that life cycle cost doesn't include. So we're just launching this mission to really transform our industry's conversation on cost, because we think this is why innovation is stifled. And when I say the job of a designer is to think bigger than your project, this is what I mean. Our job is to actually transform society through the language we use and through the way we communicate the power of what we do as designers. True costs, if we include all these other factors, will start to stimulate change. And honestly, we're just not seeing change happen anywhere near quick enough. Think about what's happened in technology in 20 years, and then think about what's happened in the building industry, right? It's kind of sad. It's because people make a lot of money on technology and people haven't figured out how to make a lot of money on this building technological change that's about to happen, or this building industry transformation. Here's some, and I apologize. I know as students, you guys are like, want to see pictures right now of like cool buildings and let me walk you through technology, but this is more important. Trust me, you'll be talking about this in the future. And I want to share this because I want you guys to start thinking about your voice in society. And here's a great way to tell your friends why you matter. Our industry last year spent $13.57 trillion, which is 16% of the global GDP. That's making buildings, right? Architects are a tiny, tiny, tiny percentage of society. We buy the materials for that portion by the specifications we make and choosing what we build buildings out of. We as an industry literally are the single biggest consumer on earth as far as our purchasing power. That's a change in who we are as an industry. We're actually incredibly important. We have to learn how to talk that way so that we can change politics and change policy. So 16% of GDP is a lot. That's actually going to go up to about almost 24 trillion, which is, these numbers are too big to even understand, but 16% of the world economy is kind of helpful. But when you factor in true cost, that number is probably 3 or 4 times higher, meaning that arguably what we do can touch 40 to 50% of the world's economy. And that's because, like in my example of sound, we impact mental health, healthcare, community and engagement, all the issues associated with climate, 42% of that, the climate conversation. We have this massive footprint and we do not know how to use our voice. And I think it's going to change. So let me take you through a little bit, a few more examples of this to help. And I did this talk for every like normal non-building related industry people for a TED Talk. So I kind of used the really simple one. So planetary cost is a whole bunch of stuff, like, you know, obviously climate change being the biggest one, but there's many, there'd be hundreds up here for planetary cost. And so I just kind of used climate change and that 42% that we already talked about that our footprint is. By 2050, the World Economic Forum thinks we're going to spend between 1.7 and 3.2 trillion just on addressing climate mitigation issues. I think that number is probably 10 times that number. I think we just really don't know this number yet. And it's hard because it doesn't factor all those true cost things that I just mentioned. But the impact of climates, we know it's going to be just staggeringly big as a cost. But most of the world doesn't put a cost to carbon. Right. I don't actually know if you guys do in Spain. Do you? Do you have a cost of carbon? No. So North America, you can't even talk about it in politics, the idea of putting a cost on carbon. But the single most important thing we could do is put a cost on carbon, because our buildings that are made out of better materials immediately become cheaper, right? Let me give you some examples of societal costs. Mental health's a big one, physical health's a big one, but there's a lot. You know, labor exploitation worldwide is a huge one, right? If you buy fast fashion, you buy a $5 t-shirt, you're probably using some sort of exploited labor, right? Well, that in the building industry is a huge problem, huge problem. And so it's the same choice. When are we going to actually charge for that exploitation so that it's not, people aren't taken advantage of? So I'm going to skim through this because I want to go a little bit fast here, but I'm just going to stop on dignity. What's the cost of dignity? So when we put in North America, we're doing this. I don't exactly know what's happening here, but as an example, our governments are trying to build housing for social housing. And they're trying, when they go out and commission, the government goes out and commissions it, they feel like to be responsible to taxpayers, they want to make that housing really economical. So they pick the lowest cost architect and the lowest cost construction. And they think they're doing a great job because they're putting people in that housing. But we all know that the quality of that housing matters a lot to the sense of identity of the people that live in there, right? When you feel proud of where you live, you start to maintain it. When you feel proud of where you live, you start to create greater connections to other people and build community. When you feel proud of where you live, that maintenance means you don't have to rebuild the building. Or what's happening where I live in Vancouver, they're building buildings out of literally temporary buildings that only last 20 years. And they feel like they're serving this public good by making cheap housing. But we're going to have to build it every 20 years, meaning the capital cost, the real cost is much bigger. These are big issues. It's hard to identify what the cost of human dignity is, but it's massive to society. And we're starting to develop tools to be able to create these costs and add them to the true cost of making a building. The next one I'll use is performance cost. And this is, again, this is a bit kind of complicated. So, because there's a whole bunch of them, but I'll use a couple of examples for you around. This is a great one for like, this is like sound, right? So if you think about a road closure, when you build out a mass timber, and I always like, I'm not promoting mass timber here as the solution, but I think any solution you guys come up with in the future has to address these kinds of issues. When you build a mass timber building, it can take months less. The impact on road closures is significantly less than if you build in concrete. And so why does that matter? Well, there's all these impacts. So when you shut down a street, the construction of a building doesn't pay the businesses that lose business, right? So we probably all walked along a street that's closed down, and those businesses, the shopkeepers are having a hard time. Maybe they lay people off, people are losing their jobs. That construction site that takes a year to build and shuts down that street for a year doesn't compensate those people. But what if they did? If they did, that's the true cost. Then they would be incentivized, the industry would be incentivized to come up with technology to build offsite. They'd be incentivized to come up with technology to reduce the amount of time that they're affecting all those people around. And it's not just the businesses and the jobs, it's your time driving and sitting in construction, the stress that you're feeling, that traffic emissions created by shutting down that road, that stress and what that means on mental health or the impact on your relationships or the time you get to spend with your family or friends, right? The compounding societal impact of the construction industry that need to be solved aren't being solved because there's no incentive to do it. But if we start to measure these things and assign these costs to individual buildings, and governments can help us do this, we start to see motivations for us to reduce the costs and therefore innovate. And these are the problems that our industry needs to solve much more than just make a pretty building, right? These are the things that impact everybody in society, not just the users of the one building you're doing. So I'll give you a couple more examples. Biophilia. I'm going to wrap up in a second here. You guys know what biophilia is, right? So using nature and obviously building a mass timber gives us a tool to bring nature into the building. So with our big client, our big tech client that I've talked about, we measured sick days and we looked at company X and said, if there's 1,000 employees in this building, we actually believe, and they get paid a lot of money in tech, we actually believe that there's a 10% reduction in sick days because of reduced stress levels associated with working around wood products and in a natural environment. And we did a whole bunch of measuring to try to figure out what this number is. And of course, it's an approximation. But if you just take that over 10 years, what does that add up to? Well, I just kind of did the math. Okay, $5.5 million. That's a savings that maybe in choosing between steel and wood, we should attach to the building cost. That's enough to make a difference in whether you get to use a material that's less now all of a sudden the cost of construction is inconsequential. And that's what matters here. What we do by the choices we make aren't just about the lowest cost building or the nicest looking building. It's about the outcomes of human health. It's the outcomes of productivity. It's a huge range of outcomes that change society if we do our jobs better than we've been doing them so far. So that's true cost. And the last one I'll just mention is process costs. And this is just kind of funny because you guys all know this building, right? The falling water. I was actually weirdly just with the engine. I touched the button. The engineers in New York that fixed this building, because there's a story they told me. I was just with them a couple of days ago, and they told me the story that Frank Lloyd Wright came on site, and the cost of the construction, the rebar was a little expensive, and he came on site while it was being built, and said, "Just take all those rebars out." And they poured the concrete, and there was like I guess 200 millimeter sag in the concrete over the top of falling water because Frank Lloyd Wright thought he knew what he was doing. The reason I have this up is about process. So a lot of people have come up to me and said, well, I don't know, there's been lots of cool technological changes in the industry. We use CAD, we use like robots, we're using all kinds of stuff. But I think about it this way. Frank Lloyd Wright drew this building, this one of the most iconic houses ever built, in 13 pieces of paper, right? By hand, obviously. 13 sheets, and that include the specifications for it. It has a totally unique 2-wire electrical system that he drew on one of the sheets, and all the furniture, all on 13 sheets of paper. So today, for making this building, we'd draw 100 sheets, we'd model it, we'd take years. Frank Lloyd Wright wouldn't be allowed to build this close to a water system anymore because that's a problem. And the regulatory process alone would add, months, if not years, for him to get the building done. All that time, all that access, and the way we're using technology has taken away from the end product, right? So we're not innovating. Our process innovation has a cost to it that should be added. And we have to innovate really to reduce all that stuff. Okay, so the last thing I'll just say is why now, and then I'm going to kind of conclude this thing. But why now is all about artificial intelligence. Everything I just described to you guys is so hard to put a number to, right? These are really complicated things. The data exists in many ways. It exists in healthcare systems. It exists in mental health institutions, educational institutions, ministries of environment, and so forth. We have this data, but it is so complicated to assign it to buildings. AI and its capacity to be able to understand big data will start to help us see these things for their truth, which is that we don't just make buildings, we transform society through every part of what we do. And the way we make buildings and how they perform has a huge societal cost. And the moment we figure them out, we're going to have the opportunity to realize the innovations that our industry so far has been afraid to realize because they just seem too expensive. And that is the end, true cost. There you go. Let's go. We gotta get chairs up here.
Yeah. Michael, thank you so much. That was amazing. I think I had like 4 questions. You responded all of them. So it will be a conversation with the students from now on. Let me introduce, no, it's okay. Let me introduce very quickly 2 other key people tonight. The first one is Kelly Doran. Kelly Alvarez Doran. He basically is a long friend from the GSD that we spent several years together. He moved to London, has been working for many years at Mass Design Group, and now he's being the satellite of Michael Green Architecture as well in London to try to push this amazing agenda here. And an expert on, I would say, holistic design, really taking in consideration all these different dimensions that are so fundamental for designing today. As well with us, we have Maria Moran, she's an architect from Spain, even though she abandoned us for many, many years to join Michael in Vancouver and in British Columbia, where she has been working in many of the, many of the projects that Michael showed today, including the Google buildings and many other pioneering buildings. And Maria is back in Spain, which is great news for us. And so it's a way of transferring that, know-how and that talent that has been developed in the kind of mostly in the West Coast of the US back to Spain to really push also the studio of Michael here in Europe together with Kelly. So I would like to invite both of you for a quick round of questions, and maybe we will open up to the students. So maybe a quick round of applause to Maria and to Kelly. Super. So I have basically 3 questions. I had like many more, but I think Michael addressed several of them, which is awesome and great. I'll probably start with Kelly because I think Kelly offers really the, as I was mentioning before, this more, what we have been calling here at IAAC, I would say trans-scalar approach to design. That one of the things that has made IAAC very unique has been not only this idea of learning by doing, that I think is very explicit, and everybody that walks around is very self-evident, right? That we put a lot of emphasis on really having this material experience, and that architecture, design, urban design, and industrial design, they are not just disciplines that one learns very abstractly, but we have to really immediately apply it and prototype and test and iterate, no? Which is something very important. But the other very important concept is this idea of I would say, scalarity, right? We try to think that, sometimes we design at the scale of the molecular when we are dealing with material innovation, but also immediately thinking what are the kind of planetary repercussions and, thinking throughout what we call the kind of value chain, no? All these different kind of steps that enables, things to be transformed and be somehow deployed in the form of buildings and many other things. So, Kelly, the question for you would be, maybe projecting a little bit, not only for what we are seeing today, but also, how do you see the next kind of, few years on, I would say, our industry, our field, our kind of like discipline in embracing this thing that, we now are starting to be, generally speaking, familiarized with, the embedded footprints associated with building, with construction, but, how that's going to progress. I mean, it's going to be something relatively mainstream, or we are truly going to embrace a design that, from very soon, questions of, carbon credit, the distance where the materials are being sourced from, truly become, I would say, a driver for design. No, I mean, we have seen some of this emerging, obviously, in the practice of many people, including kind of like Michael. But as also you were self-reflecting, right? We are still very far away from the true impact that we can do. So I would love to hear your thoughts on, that somehow transition and how, our practice might shift, from this crazy period of full globalization where we were having the luxury, of bringing the materials from the other side of the planet to something else that, clearly is telling us that model is absolutely wrong, and we should be, paying very, very much attention to those footprints.
Yeah, that answered your question a little bit. I would tend to agree with you. I think the regulatory environment around embodied carbon, requiring LCA, setting targets, certainly across the EU right now. The answer to that is twofold. It's through bio-based materials and the reuse of existing materials, and limiting further extraction of virgin materials, specifically metals. And what that means, I mean, back to the kind of history of the last, reinforced concrete being the invention, I think that was most critical that you're referring to. Pre-reinforced concrete, the family materials that we relied on were stone, masonry, wood. There was a fifth that was stone, but I guess stone's wrapped up in masonry. It's a return to those two material families. Can you grow it? Is it rapidly renewable? What can we do with it? How do we innovate in that space? And does it already exist? And when I graduated from grad school 15 years ago, I went and worked in the mining sector for 3 years. And what's remarkable to me is that right now we have a great sense of all of the materials that exist below the Earth's surface, but we have very little understanding above what already sits above it. And really excited to see somebody crushing bricks in the back here today and making something new out of it. This is a big part of the future, along with those biomaterials. And I think inherently there will be a rediscovery of kind of regionalism to it. And like a pedagogical question I've always had is like, whatever happened to the critical regionalist movement of the 70s and the 80s? What suppressed that? And, thinking to how we teach design, it coming back to some form of understanding of the people in the place and the processes that you work within. And I think that is certainly the future of both practice and pedagogical models.
Thank you. No, it's absolutely true. I think we are gradually moving there, at least from a narrative or discursive perspective. But it's true that the reality of the day, it's still preventing us to maybe do the changes that we would love to see from implementing those a little bit faster. I don't know, maybe Maria, since again you have been at the core of many of these key projects in Michael Green architecture. I'm curious to know, which type of innovations beyond, let's say, the use of mass timber, which, is extremely kind of explicit and is the solution we have ready now. We have the technology, we can build with that. But obviously, I'm sure that you guys have been pointing to a few other things and using projects potentially to explore other things. One of the examples I love that is obviously connected with mass timber is the case of the building that you guys did, the Innovation Center in Vancouver, right? One of the earlier works that you guys developed in the use of also pines that they died because of the beetle, how you call it? Like the mountain pine beetle, right? So this is basically, if you could explain it correctly, no? But in a way that was the use of these deceased trees that, basically if nothing was to be done with them in the forest, they will decay, release back all the kind of carbon. So in a way, there was a kind of pulse or a surge of material available there that needed action to store that carbon. No? And so, for instance, this was somehow incorporated in the building, in part of the facade. No, also because it has unique kind of aesthetic kind of characteristic besides the very meaningful ecological function by removing them. No, so this is probably one small example, but I'm not sure if you guys have been digging deeper in the use of other bio-based materials. We, as you have seen here in this amazing collection of many things that we do, we are also jumping now into cork and try to see what we can do with cork as a bio-based insulation material. So I don't know if you have had the opportunity of finding other areas of innovation. Obviously, having mass timber as the core, incorporated in some of those projects you guys have been working with.
So no, it's not that. Is it really hard to implement in buildings when materials are not already tested and already proved that people have been using them for many years? So we certainly tried many times, and well, we use, like, for example, another cool story for another project is that we, like, in one of the our projects in US, it was a renovation of a school, and the original structure, it was wood, but the building had to be torn down. So we reused some of the wood inside the building. So that was one. Is one of the pictures that Michael showed in the which is a beautiful stair. And like, we thought that was important to actually tell part of the story of, like, the old building in the new one. But really, like, a lot of the innovation comes also, like, from prefab in our buildings. It comes from monitoring, like, the structure, like like the humidity and kind of, like, monitoring all those things that we can then learn from the building and then use it again for to learn from that. And especially, like, for example, on one of the like the Google projects.
We're just saying it now.
Yeah, no, the prefabricated facade that was one of the big innovations, the first done in North America. That was that was a good one to implement, and it's also, like, connected. It's actually, the inside cavity is full with Acquoia blinds that they're connected to the roof, to a weather station, and it is all programmed as well, but also connected to the station there. So, like, it can like, the blinds move up and down depending on that as well. So those are the biggest things that we can, like, nowadays implement. Like
No, it's great to hear, and maybe as a follow-up of that, in talking with another kind of pioneer of the use of mass timber, Andrew Bound, good friend as well, he always mentioned this idea that there was no research available for many of these questions, and that research and that innovation needed to happen somehow inside the studio, right? So I'm sure that, again, maybe it's true that there are certain innovations that will need more time to occur, but there are many others that need to happen within the office, even though it's a professional practice where you are supposed to be just delivering services and doing buildings, but you need that kind of research kind of platform to do many things that otherwise you don't have the response to. No,
this is we organized this bio-based summit in Boston last November around these basic questions, like, we wanted to use this compressed straw panels and some of the housing we were doing. And like, could you supply one of these 200 unit projects? You do single family residential. Well, no, we can't. And why? Well, the existing fire codes and there's this and then that. I'm like, well, if we get past this fire code, could you supply us? They're like, yeah, well, maybe, but then it's a question of scale. So we brought 60 people into the room for a day from across the entire value chain. And everybody kind of had the same message of like, what's prohibiting the kind of rapid uptake of bio-based materials. Like there's certain barriers, but I think the main thing is communication, the public understanding, being comfortable. And I think the other reality is that regulatory process, there's been systematic regulatory frameworks put in place through very strong lobbying efforts by material producers in the industry that are backed by incredibly large sums of money. Big foam, let's just call it what it is, right? Big foam, big oil, the plastics in our buildings, other industries I won't mention here, but they have made the system of approvals of going through the lab testing. It's become very difficult and costly. And if you're a small upstart, like, we want to really test this thing, you're like, shit, we're facing like 2 years of lab tests and trials to get through all this. The only way we're going to work to do this is by working together as an industry and building a bit of a kind of like consortia to team up. It can't be the responsibility of one office to figure this out, right? It needs to be an association. We need to act like, frankly, we need to act like a cartel because we're competing with cartels. That's what they are. And it needs to be a completely different culture. We need to build around this and work together.
So we learned this a lot in the mass timber movement, is that for some reason, every country thinks that fire is different in their country, which turns out that's not true. But this is the general problem, is that, we want to work with wood fiber insulation. We can't. It's just like, our codes don't allow it. It's really complicated to get it through, as Kelly said. But of course, other cultures use that, right? So there's this lack of sort of universal testing is a real problem, right? Where every jurisdiction, every country seems to want to require its own very unique, special, very expensive testing that takes a lot of time. And yeah, I think Kelly summarized it really well. It's, unless we see I think a global solution to those things, it's just it's going to take a long time to see that change happen. Andrew Waugh, our friend in the UK, can barely build timber now in the UK because of the Grenville fire, which had nothing to do with wood. But the insurance industry has decided anything flammable is too expensive to insure. It's not science-based. It's just based on a sort of reaction, right? And so we're facing a lot of these challenges to make these changes happen.
But let me be a little bit of a devil's advocate here, because while I completely agree that there are certain things that are, let's say, global about the use of mass timber. Let's say fire here is the same as in Vancouver, and is the same as in London. As a phenomenon, as a event to prevent from. It's true that timber has so many regional aspects, right, that inform the type of practice, the type of forest you have, the type of industry. So one of the things, for instance, that, as you know, we have been trying to push here in Spain is a network that is really trying to operate almost as a cartel, as a lobby, to try to help and accelerate, because the inertia of Spain building with brick and with concrete and with steel is so hard that unless we kind of gather and coordinate the efforts to try to really catalyze the change, nothing is going to happen. But one of the realizations that we have very early on is that should we create a kind of pan-European network of that? And, the conversations in Spain are nothing to do with the ones that are happening in the UK right now, nothing to do with the ones that are happening in Sweden. So nothing, the ones even in France, that is our neighbor country. So it became very clear that, we should have these more national networks, because the conversations here, and even still, the conversation today in Barcelona is very different from the one that might happen in Sevilla or might happen in Galicia. So even, it's very hard to find the right kind of like scale. So back to your point, how you see those, small networks really playing out, right? Because again, what has been happening is like, leading pioneering offices doing the research on their own because of the incapacity of finding the solutions elsewhere. Now we're seeing these networks starting to appear that maybe are helping, but still, I don't know if I picture a kind of global, I would say global in the sense of globalization movement for mass timber. It will have to be a global movement out of these regional efforts that are very, very specific, right?
Right. So yeah, the example I'd give that we went through that was exactly what you're describing is that, so does everybody here know what fire stopping is? So when you have a floor and you want to prevent a fire from moving from one floor to the other, and you have pipes drilled through the floor, you need to be able to seal fire going through that hole, right? So Hilti is a huge global company that makes a fire stopping material. When we first were building in mass timber, we could not convince them to use a product that they're used to using in concrete to use it in wood. So we had to pay and find money ourselves as a practice to convince them to do the test to start to be able to allow this fire stopping. Without fire stopping, there's no mass timber. We could not build these buildings without getting somebody to do this. This is a global company, right? So now they have a whole brand around CLT and all the products they make, and they're very proud of it. But they were total jerks in the beginning of how we had to pay for their test to build their business to become who they became. The point is, like, I think that's a good example where that test should be usable in all these different countries, as opposed to like having each country have to go through that test, which currently is the case, right? Because that means we have a lack of incentive for companies to actually build products around these opportunities, right? And again, all this wraps into the true cost conversation.
Yeah, no, completely agree. And I mean, we are seeing that change kind of like happening progressively. And again, above all, where I get really excited about what we are witnessing now is that, the big capital that at the end of the day is underlying pretty much everything we do is starting to be very sensitive to that. They don't want to pour their money even for a investment into a toxic asset. And they are starting to realize that pouring your money to develop a concrete building or a steel building, very soon it's going to be a toxic asset that nobody wants to invest in. And this is, again, Spain is just the beginning of this kind of wave. And I'm talking just because I know very well this local context, but it's even still here, we are seeing how they select, I mean, again, people that have money to invest is because they have extra money. This is not the money that they need to eat every day, right? So they are being very, conscious. Obviously, everybody wants to make a good investment, but nonetheless, they are starting to detect that, the toxicity of this built environment kind of like assets matters. And I think there is a great opportunity there. Maybe last question for the three of you, because this is a question actually I was thinking now that I asked to our friend Andrew in a taxi from Amsterdam to the airport. And I said, like, Andrew, I see you as a kind of as a kind of wizard that has a kind of crystal ball that it can predict the future. No, I mean, like, you guys have started this, I don't know, 15, 20 years ago, right? You know how a mass timber building is going to behave because you already have a history that, Murray Grove has been already up, like almost, 15, 16, 17 years, 2008, I think it was, or 9. So yeah, like 15 years, something like this. No, so tell me, what should I know? What should I, design for? What is the main thing? And we always, hear about the fire and the classical myths about timber, but in reality, I mean, our buildings comply with the same code that any other building. So there is no really discussion, right? So I was asking him, what should we really, be careful about? What are the recommendations that you would do? Because right now we are just in the kind of excitement era where we have done a generation fantastic buildings, especially in Barcelona, but in Spain, that they have 2, 3, 5 years, 6 years the most, no? But there's still very, very short kind of history to really know what's going to happen in the future. So I was asking that, what recommendations do you have? What are the things that we should be paying kind of more attention, knowing what happens, several years after?
Okay. So I think like one very important thing that it comes from experience is like to learn about the myths and methods, like or like all the things around construction that come with building with wood. With building with everything, but with wood, it has its own particularities. And yeah, just being able to really plan for reception of the materials, like weather protection of the, like having those plans really well thought through, and really like having like everyone on board with the same ideas, like the contractor, the architects, the people on site, and those are very important things that can solve you a lot of issues later. And that's my first take, so I'll let them also speak.
I think what will be radically different, let's say like 20, 30 years, is, the world is going to be hotter and wetter and more severe, and we're going to see migration at enormous scales in this country, like even in this country, there's going to be a lot of migration, where cities are going to grow exponentially. And this enormous challenge of like, how do we reduce emissions and continue to build for this new future is such an important question, but why it's, again, an amazing time to be an architect or in construction, because like arguably we're amongst the most important professions to address this question. And I think that the rules that currently govern construction, I've recently spent a lot of time on planning policy, and today we visited a mass timber building that had a 2-story basement for parking because the city insisted on minimum parking for it, right, in a lagoon. And so of all the carbon in that building, it's all in a basement for no good reason, because it's a city policy, minimum parking requirements. So it's interesting to see that as a requirement also in Barcelona in a lagoon. I mean, these are the rules. The future I foresee is the data that you're building here and the knowledge that we can share from city to city. It's very regional, but there are some things that are consistent across the world, and we got to change the rules that govern us. Because I think many architects come out and just assume that, well, those are the rules, that makes sense. Let's just do this. So many of them have to change. And the buildings that we're going to design in 10 to 20 years are going to be so different. I think they're going to look like they're going to have more to do with the buildings built 150 years ago than the buildings built 50 years ago. And why it's exciting to be in somewhere like Barcelona, where you're surrounded by the clear, obvious ways to design for, the climate that, on a day like today, and in the middle of winter, like, our grandparents, great grandparents, and everybody before them were really thinking about these questions. And we'll come back to those.
So AI is going to change a lot of really interesting things in 5 years. And I think the decision making we make, and the capacity to make better informed decisions is going to be hard for us to wrap our heads around right now. All of the policy part of this will be able to be evaluated, like that kind of decision, in a much more holistic way very quickly. We're finally seeing the first implementation of AI generated planning approvals. That's going to transform cities very, very quickly, because it'll become a much less, hopefully, AI's I mean, I'm both optimistic and obviously, aware of the risk, but I think it starts to mean that these sort of opaque policies that might, say, build a green building, oh, and you need a parking garage, and you need, to accommodate all these non-electric cars or whatever. I think AI-based systems will just be a hell of a lot more intelligent than we are about integrating all these things to say, actually, the true cost is X, right? And that change, I don't think we're ready for that, because it is going to change, I think, every part of how we all practice, and probably within 5 years, our industry will be a very different thing. Buildings, I agree, they're going to look more like they did a century and a half ago, probably, and be much more intelligent, but not because of us.
Fantastic. So thank you, the three of you. Now over to you guys. I hope I see already hands raised. So maybe Alice, you can help us. Perfect. So we will take like 10 minutes of questions, because we are running a little bit late, probably. Yes. So be concise, to the point, and we will try to get the right answers to you.
I would like to ask mostly about the opportunity also,
and developments regarding the existence of forests. But at the same time, I put a lot regarding the benefits in human beings, and I would like to have visited that and what
I missed the question. Sorry, can
Yeah,
you repeat
yeah,
that?
so
Earthquakes.
the size of
Yeah.
the city.
Yeah.
No,
You want to do that one?
no, you can do that.
Yeah, so where we live is highly seismic. So Vancouver is on the west coast where the Pacific plate hits the North American plate, and they're all the way from California, we're really all the way down to Tierra del Fuego, all the way up to Alaska. It's an earthquake zone where we live. So we have very high seismic requirements. Part of the reason our way of thinking about mass timber is so completely different than my friend Andrew Waugh, and why our building approach is so different, is because of earthquakes. The way the first Murray Grove building was built is a platform-based solution. So walls, floor. That would not work for us in a high earthquake zone. So we've worked with a lot of the first technologies for really, I guess, the first technologies for how to build very tall, high seismic buildings. But again, we're attached to building codes. On the Google project, our entire lateral system for earthquakes had to be steel because the building code would not allow it to be wood, even though technically we could do it in wood. The next state north of California is Oregon, and we built what's called a rocking shear wall. It's pretty cool. That's a timber-based solution that allows, in an earthquake, for the building to snap back into place, to deform and then come back to place. It's a technology that was developed by some engineers in New Zealand. So there are really cool technologies out there that will address seismic. The best part is, and this again goes to this like mantra I have around true cost. Most people don't know that the building codes in most countries, especially in earthquake zones, require that you can walk safely out of a building and that people don't die and the building falls apart, right? They do not require that the building is usable after a big earthquake. So what that means is if we get a big earthquake in cities like San Francisco, Vancouver, Los Angeles, most of the city that's built in concrete, those buildings will not be usable anymore. That will basically end most of those cities for 20, 30 years. The cost to society of that is something nobody's imagined, right? But this is what happened in Christchurch, New Zealand. So the way to solve that is timber, because it's repairable in a rocking shear wall solution, and concrete buildings are not repairable when there's ultimately yielding of the rebar. So this is a really important concept, right? The economic footprint of wiping out a city in an earthquake, not because the buildings fall down, is something that nobody's really talking about and need to, right?
Question? Yep.
Yeah, Frank. Hi, Frank.
There are a lot of developments happening when it comes to recyclable materials and materials which are recyclable from waste. So have you worked on anything like a common between mass timber and
Some other, it's like material.
there are a lot of developments going on in that direction.
I mean, I can't speak to the work that's happening, but this is the future, guys. Like, if it feels like it, I walked in, I'm like, hey, this is the future of architectural education right here. You're in it. The future is reused and bio-based. So what you're doing in the marriage between these systems, how they integrate, how the brick with a geopolymer getting ground up, made into something new that's probably, climate positive potentially, and like how you're doing it. Like, this is where we need to do the R&D. And I think back to the kind of regional specificity has to do with, I always use the parallel of the food systems and what we've seen in food systems in the last 10 to 20 years. We need to see that in the construction sector. The work you're going to do here is going to be very specific to the biome, of Catalonia, of this part of Spain, etc. But the systems and ways that you're doing it are probably transferable back to many other parts of the world. And it's that relationship, I think, is what's really exciting. And back to the regulatory piece, there are some things that are universal, and then there's some processes that are also universal. And I think it's like figuring that out and how we exchange ideas is critical. And the role of an academic institution, I mean, as an institution, and we were talking earlier about what is the role of architectural education, you know, it's to create this, is to incubate these things. We need these ideas because they start here. And so, I mean, I would just say if you're going here right now, very exciting time to be at IAAC, it seems to me, having just walked in the door only 2 hours ago. Yeah.
Oh, can I-
Yeah, go.
just one. No, yeah, and just like when you're designing buildings, like thinking about like how the end of life of that building is gonna be, like how can you decouple different materials, or like what is going inside, you know, the binding, like all the different glues that comes with it, and how can that be reused in the future?
So I just want to add to what Kelly said, that is a really important thing, is that if you guys were all software engineers, you'd be trying to figure out how within a year or two you've sold your first company and made millions of dollars, right? That's true. And you'd probably come up with a really cool idea and kick it out into the world, and some investors would be super excited about buying your idea. If you're a software engineer, everybody in this room would probably be thinking that's their future. And most of you, that would be true. That's the way you need to be thinking right now. You come up with a material innovation, we're going to start building the infrastructure so that the investment community understand that you will make far more money figuring out what we all do than any tech individual ever made. I believe that people like Elon Musk are small potatoes to the people that figure out the future of construction to revolutionize what we do in a really, really aligned way with how the planet needs to be in the future. But the investment community don't know it. Like I said, we're the largest consumers on the planet with the smallest voice. That's got to flip. And if you're interested in material innovation right now, I swear to God, start imagining selling your first company for many millions of dollars, because it will happen.
And please remember IAAC and give a percentage to IAAC when you do. Very important, very important. Okay, so thank you so much, Kelly, Maria, and Michael, for joining us this afternoon at IAAC. It has been a true pleasure to meet you and to share, you know, a couple of hours probably now, or like 90 minutes. That's also, you know, part of the Spanish idiocracy that, you know, we time sometimes doesn't matter. What is important, exactly. So anyways, thank you all. Thank you all for attending. And please, one last round of applause to Michael, Maria, and Kelly. Thank you.
Yeah, of course.